Hello guys again. So this is the Webassign for chapter 2, motion in one direction. There are 13 problems, and even though we have the agreement of 80% for 100% of your grade, so that means that if you have 80% on the assignment, you get 100% in the grade book. I would recommend that you attempt as all the problems on this assignment, because these are like mini quizzes or mini tests for each chapter. They allow you to master, in some cases, the problems, to read it, watch it, right? So I actually want to start with this problem because this is about average speed. We have talked about average velocity a lot, but we didn't really discuss much about average speed. Average speed is just the total distance divided by the total time that you take. And in this case, you don't care about the direction of motion. So I want to change the numbers a little bit just to make it easier, but they tell you that a person walks at 5 meters per second from A to B, and then from B to A at 3 meters per second. What is the average? The average speed is not 5 plus 3 divided by 2. So it's not 4 meters per second. The average speed, if you are traveling certain distance, all right, from A to B at first 5 meters per second, and then you are going back at 3 meters per second, let's put like this so you know this is the speed, is the total distance divided by the total time. But here you are going, right? The average velocity will be 0 because you end up on the same position that you started. So if I consider this distance to be d, right? Then I can certainly say that the average speed will be d plus d, that's the total distance, divided by the time to go to the right plus the time to go to the left. Let's put it like this. And the thing is, how do you find that time to go to the right and the time to go to the left? From this information, he goes to the right at 5 meters per second. So the time to go to the right is the distance, only d, divided by 5. And the time to go to the left is the distance divided. Remember, we don't care about the signs in here. So d over 5, d over 3. So here I will have twice the distance divided by d over 5 plus d over 3. So you see, it's not really like an average, right? And what happens is that the value of d will cancel by algebra, and then you will have 2 over 1 over 5 plus 1 over 3. So you will have 2 over common denominator 15 over 8. This gives me 30 divided by 8. This is approximately 15 divided by 4, 3.75. So interesting, right? We don't get 4 meters per second, we less than that. Yeah. So that's the procedure. The numbers that you get in the Webassign are fractions, or like, I think they give you, don't want to get decimals. So that's the procedure. Understand it. It's basically what you have to do. And I already gave you the answer for the average velocity, right? Here. The other problem I think is interesting is the one that why not? Let's do this guy. A baseball is hit so hard that it travels straight upward, and then a fan observes that it takes 2.9 seconds for the ball to reach the maximum height. Find the ball's initial speed, initial velocity. They already give you the direction. Find the height it reaches. So I did this problem in the last video of part 2, right? So let's do this problem now. Again, I could just change it to 3 meters per second, but whatever. Let me show you what happens if you have decimals. So a ball is hit with some velocity, and we're going to ignore the height of the person. So it goes up until a point here. And they tell you it takes 2.9 seconds, right? So all this takes a time, delta t, of 2.9 seconds. Now, if this is a maximum height, so the velocity final on y here is 0 meters per second. And obviously, you're going to be hitting this ball with some velocity initial y. You have everything you need, because you know gravity, which is always going down, is 9.8, well, the magnitude, right? Technically, it should be negative. So velocity final on y equals to velocity initial on y minus 9.8 times time. But what's time? That. And what's velocity final on y? 0. So this is 0. So they ask you for the initial velocity, right? So 0 equals to the initial velocity on y minus 9.8 times 2.9. So the initial velocity going upwards is 9.8 times 2.9. That will be approximately 28 meters per second. So that's awesome, right? In fact, it should be J. It's going up. How do you find the maximum height? There are two ways you can find the maximum height. There are two equations you can use. You know that delta y is v initial on y times time. In this case will be minus 1/2 gravity t squared. You have time, you have gravity, you have the initial now. You can replace and find delta y, which is the maximum height. Or you can use this. V final on y squared equals v initial on y squared minus 2g delta y. Why am I saying that? Because you know this is 0. You have this in here. Gravity, you know, is negative, well, 9.8, right? And then delta y. Right? So if I was to solve the equation for the maximum height, let's say I use this one, it was 28, right? So 0 squared equals to 28 squared minus 2 times, it's minus because gravity is going down, times delta y. Now delta y equals to 28 squared over 2 times 9.8. So, and it will be meters. That's the answer. Nothing difficult for that problem. So it was good to review falling objects. Let's do one of these graphs. I'm not going to give you all the answers, but I'm going to tell you to be very careful. For example, here they give you a position versus time graph, right? So they want you to find the velocity or the average velocity between 0 and 2 seconds. 0 is here, 2 is here, right? So I just want the slope of this line. The slope of this line will be 10 divided by 2, 5 meters per second. So I got this. Between 0 and 4. Okay, so you want the velocity between this point and this point, right? We know that average velocity is the change on position divided by the change on time. The position on 4 is approximately 5. The position on 0 is 0. And then you have 4 seconds. So 5 over 4, 1.25 meters per second. Positive. So I have that. Between 4 and 6, by the way, between 4 and 5 will be 0, right? It's a horizontal line. It's on the same position, so 0. But between 4 and 6, guys, and that's the last one I'm going to do, okay? So you can already see the pattern and the idea. But the average velocity between 4 and 6, you write it like this, by the way, is a position on 6 minus a position on 4 divided by 6 minus 4, 2 seconds. What's the position on 6? 0, right? You go back to the origin. You don't look at this number, you look at the fact that the position here is 0. 0, what's the position on 4? The position on 4 is 5 divided by 2. So I get now negative. That's fine. Velocity can be negative. That means you are going backwards now. Minus 2.5 meters per second. Easy, right? So I'm going to leave it in there for a bit. All right. You are going to get a problem like this in the quiz for sure. Okay. Positions versus time graph. Which one I think? This one I did in the lecture. Check the lecture, but it actually takes you step by step. Okay. This one is an interesting problem. I'm not going to do all of it, but I know some of you are going to have confusions. So might as well do it, even though you might get a different function. The height of an helicopter above the ground is given by the function h equals to 3.30 t cubed. It's a cubic, where h is in meters and t is in seconds. At time 2.05 seconds, the helicopter releases the small. Okay, when we release something, let's suppose I release right now my marker. The initial speed of the marker will be 0. That is true. But let's suppose you have now a hot air balloon, or like they give you here an helicopter. In that particular case, since the helicopter and the hot air balloon are going up, right? Whatever you release is gonna acquire the speed of the balloon or a helicopter. We are gonna understand that more when we study Newton's laws. In Newton's laws, there is something called the law of inertia. Actually, the first law of Newton, Newton's first law. So that's gonna make more sense in that, or we're gonna be able to explain that. For now, just think what happens if you are in a car. If you're in a car and you all of a sudden stop, you go forward, and you go forward because you and the car are moving at certain speed, not just a car. So whenever you release something from a helicopter going up, then the thing will go up, but eventually will go down because of gravity. Now, gravity is always acting in this case, right? So how will you do that problem? In fact, let's actually check what they're asking you. Okay. They're asking you for the how long after each release does the mail? That's an interesting problem, huh? So you are basically having an helicopter, which obviously is above the ground. So there. And you have that the height of the helicopter is increasing. The helicopter is going up. This is the helicopter, right? So it says that the height is, you're going to get a different number, but probably similar, 3.30 TQ. So when you release the mailbag is going to do this. Nice. So how do you solve a problem like that? Right? By the way, gravity always. You want to know how long it takes to go up and down. Very similar to a problem we did in class, by the way. We know that the velocity at this point is 0. The velocity and the speed at the maximum height. How do I use this piece of information? Well, h is on the y-axis. So I can say that y for the helicopter is 3.30 TQ. The velocity of the mailbag going up is the same as the velocity of the helicopter going up. That's the initial on y. On y. So what do? I take that derivative. You know why I take the derivative? Because it's a function of time. The derivative of that will give me the velocity at any instance. That is my velocity on y. But they tell you what time are they interested. They say that the mailbag is released at t equals to 2.05. So I'm gonna compute v at t equals to 2.05, which is 9.90 times 2.05 cubed. So I'm using Webassign numbers. I could have changed those numbers a little bit. For a quiz, I'm probably gonna give something, or would most likely give you numbers that are. Let's do this. So 85.3. That's the initial speed, initial velocity of the mailback. So I know that this is this. And I know here, B final on Y is 0. So I can tell by using gravity how long it takes to go up. And then I know how long it takes to go down, right? The other thing you need to know, if you remember the problem we did in the lecture, is we need to know how much is H. So this delta Y, that's the value of H. But we need H at this time. So here, we need H at 2.05. 3.30 times 2.05 cubed. Wait, my bad. Sorry guys, this is square. Square, so this is a wrong number. Okay, let's calculate those numbers again. 9.9 times 2.05 times 2.05, 41.6 is here. And H on 2.05. Cube times 28.4. So the height is 28.4 meters. That's delta Y. To find the time going up, I use my equation. Now we know gravity is constant, right? So we can use the equations of motion. I have the final, the initial gravity, then B final on Y, B initial on Y, plus, but with this minus 9.8 time to go up. So the time to go up is 0 is equal to 41.6 divided by 9.8. That should give you approximately 4 something. .24 seconds. Actually, 4.2 seconds. Excellent. So that's the time to go up. To find the time going down, so here, you need to know the initial speed, which is 0. And you need to know the total height. But guess what? You already know part of it. All this is 28.4. Your task will be to find this, I'm gonna call this H prime. How much it goes up, right? To find H prime, I would recommend, let me see, you're looking at this part of the board. Yeah, so to find H prime, use this, B final on Y squared equals to B initial on Y squared plus or minus 2G delta Y. This, well, you can change this to H prime. You need this. You have this is negative, so that will be negative, right? B final is 0 and B initial on Y squared You have initial on y. The initial on y is this. If you have this h, you add it with this, and then you use free fall, because h prime plus 28.4 equals to 1/2 gravity t to go down square. And what's the total time? T to go up plus T to go down, that's the total time. So this is a very interesting problem, all right? Seems a bit long, but I think there's a lot of learning goals in that problem. This one now is a velocity versus time problem. The only thing I want to tell you guys is to be very careful with the divisions. So here, each square is 2, 4, 6, 8, 10. So each square is 2 units or 2 meters per second. Here, each square is 1. 1, 2, 3, 4, 5. That's 5. This point is 6. This point here is 10. This point here is 13. No, sorry, 14. This is 15. So be very careful, because they can trick you with that. For example, this is a velocity versus time graph, right? What's the object acceleration between 0 and 4? 0. Because the object is not changing velocities. So 0, right? So here will be 0. What's the object acceleration between 4 and 10 seconds? So between 4 and 10 seconds, in this particular case, you could actually apply the slope, but let's use a definition. You want to know the acceleration will be the velocity on 10 minus the velocity on 4 divided by the change on time, 10 minus 4, 6. What's the velocity on 10? Is here, right? 12, 14, 16. Minus the velocity on 4 will be here. Minus 10, minus 8, minus 6. So, divided by 6. This is 22 divided by 6, 11 over 3, approximately 4, 3.8, 3.9. So you get this, you got this here. This is part B. And then you can do the same for part C. Now, look at this question here. This is going down. At what time is the object moving with the lowest speed? Guys, just because the velocity is negative doesn't mean that that's the lowest speed. For example, if a car is moving to the left at 10 meters per second, that means that the velocity is minus 10, but the speed is 10, because the speed is the magnitude, the scalar. So you are only gonna get there the lowest speed when it's not moving, when it's 0. And you can clearly see there when it's 0, right? It's in the graph. It's pretty obvious. So when the velocity is 0, that's the lowest speed. That's why they give you 2 values here of time. How do you find the displacement and the distance? The area under the curve. But be careful though. You have 2 sections here. You have this section below the x-axis or the time axis, and you have this. So if you were to find the area here and the area here, right? The distance will be the sum of the areas. The displacement will be the area on the top minus the area on the bottom, because technically the area here is negative. In fact, let's calculate the areas. Here this point is 4. This point is 15, 16, 17, 18. So all this, right? Let's erase it. I don't want that. All this is 14. That's the major base. This is 10, this is 14, this is 4, this base, and the height is 12, 14, 16, right? This height is 16. So the area of a trapezoid is the sum of the bases divided by 2 times the height. So the area here will be the sum of the bases, 14 plus 4 divided by 2 times the height, which is 16. 18 divided by 2 is 9. 9 times 16 is 144. 144 meters. That is the area here. Positive. This area, however, is negative. It's another trapezoid. The major base is 6 now, right? Wait. So why did I say here? Why did I put? My God, this is 12. Sorry, guys. I don't know what I'm thinking today. 5. Thinking that is 4. This is 12. So this is 12. Always check your work. You always have to check your work. It's always small mistakes that can throw your answer away. 16, 8, 108, 16 times 8, 128. 128 meters, right? You guys are gonna get different numbers, but just be careful. Look at the mistake I made, right? So that's what I'm saying. You have to, maybe you want to label this as 6 at the beginning, so you know. This is 6. This is 1, 2, 3, 4, and the height is 10. 6 plus 4 is 10 divided by 2 is 5 times this is 50. So this area here is 50 meters. 50 meters. Technically, it's negative. So the displacement, which is the final position, will be 128 minus 50, 78. Right? Let's not make you guys confused. So here. The total distance will be 128 plus 50, 178, right? Makes sense? Yeah. Okay. That's because at the beginning it's moving to the left. Up until t equals to 6 seconds. The first 6 seconds is moving to the left and then goes to the right. So there you are. All right, guys, I think that should be very self-explanatory. Oh, this one is also quite interesting. So here they give you the definition of jerk, which is the rate of change of acceleration. It says, assume an object moves in one dimension, x direction, and assume that the jerk is constant. Determine expressions for A, B, okay. So that's not that bad. Let's use that. Let me just double check if that's what they're looking for. Yeah, okay. So, oh, they give you the initial values, AI, VI, XI, okay. So, if they give you the jerk, and they want you to find the acceleration, the velocity, and then the position, what you're gonna do is as follows. Jerk as a function of time is the derivative of acceleration per time. But they tell you that it's constant. So J is equal to dA respect of time. You multiply by dt. It's also a vector. dt equals to dA. And, well, I can integrate on both sides. J is a constant. I'm gonna go from 0 to t, and this is gonna go from some initial value of the acceleration to the one that you want. So J is a constant. T minus 0 is just t. That's equal to A minus AI. So I can say that my acceleration as a function of time is AI, the initial value, plus JT. But we also know that this guy is a derivative of velocity respect of time, which is AI, initial value, plus JT. We are going to multiply by dt. So dv equals to AI plus JT all multiplied by dt. And I'm going to integrate on both sides. I'm going to integrate from v initial to some value of v as a function of time. And obviously here I'm gonna go from 0 to t. V minus v final, so the velocity as a function of time minus v initial equals to, how do you integrate this? That's a constant. So AI t plus j t squared divided by 2, or 1/2 j t squared from 0 to t. On 0 that will cancel, on t will get that. So then the velocity, right? The velocity as a function of time is v initial plus AI t plus 1/2 j t squared. How do you get a position? Well, you do the same. Dx dt equals to all that. You integrate it from xi to x, from 0 to t on the other side, and that's how you do it. All right. All right. All right, guys, that's basically what you have to do. Okay. If you have any questions about any problem on this assignment, I will try to have the video or office hours, sorry. Okay. And make sure that everything is clear from there. All right. Awesome. Yeah. All right, guys. That's it.